Okay, so let's try some example problems going from grams of one substance to grams of another. So if I burn 150 grams of methane, CH4, with plenty of oxygen, how many grams of water will I produce? So as I read through this problem, I'm going to underline my given, which is 150 grams of methane, CH4, and I'm going to circle what I'm trying to find, which is grams of water. Now, we think about the four-step process for stoichiometry. We first need to get our balance equation, so we'll write that next. We're then going to take our given and convert it into moles. So we're going to use molar mass to go from grams to moles. Then we use the mole ratio to go from moles of my given to moles of my product. And then we want to go ahead and convert our second thing into grams in this case. The thing we're trying to find from moles to grams of water. So we're going to use molar mass of water for that part. So let's go ahead and work through this. So the first thing I need is a balanced chemical equation. In this case, I am told that methane is burning. So if I think back to our reactions unit, remember methane, CH4, is a hydrocarbon, and it's going to react with oxygen to produce two products, CO2 and water, H2O. Okay, now we want to balance our carbon first, which is already balanced, our hydrogen second, so we're going to put a 2 in front of the H2O, and then our oxygen last. So I have 2 oxygen here. I have 2 plus 2 is 4. So I put 2 in front of the oxygen to end up balancing out my equation. From here, I want to start to set up my factor label table. Remember, the given always goes in the first spot, and I want to be specific, including both my unit of grams and the compound I'm talking about, CH4. If I have grams of methane up top, I need grams of methane down below. So this is step 2. I'm going from grams of my given to moles of my given. And the way I'm going to do that is using molar mass of CH4. Okay, and the next thing I need to do is step 3. I want to go from moles of my given to moles of my ending point, which is water in this case. Okay, so that's step 3. I'm going to use my mole ratio for that. And then the final thing, I'm going to use my molar mass this time of water to get to the grams of water. So from moles of water to grams of water, which is what I'm trying to find, I'm going to use the molar mass this time of water. Okay, so I have my table set up as a skeleton. Now I need to fill in some of the numbers. So the first thing we need to do, let's go ahead and calculate the molar mass of methane. So I'm going to take the mass of one carbon, which is 12.01, plus 4 times the mass of hydrogen. Each one is 1.01, so that gives me 4.04. So if I go ahead and add that up, I get to 16.05 grams per 1 mole. So the 1 mole goes up top, that 16.05 goes on the bottom. Now be careful what molar mass you put in each spot. This case, we're talking all about methane, so we need to make sure we use the molar mass of methane. But I cannot use those same numbers here because now I'm talking about the molar mass of water. So we'll calculate that very, very soon. For my mole ratio, I'm going to look at my balanced chemical equation, the coefficients, to find the numbers that I fill in. So for methane, it has a coefficient of 1, and water has a coefficient of 2. Okay, and then I need to find the molar mass of my water. Okay, so I know I have 2 hydrogens, so 2 times 1.01. And I have 1 oxygen, so that is going to be 16.00. If I add those up, I get 18.02 grams per mole. So 1 goes on the bottom, 18.02 goes up on top. Okay, so remember, numbers on top I multiply, numbers on the bottom I divide. So 150 times 1 doesn't really change anything, times 2, and then times 18.02. And then we're going to divide by what I have in my bottom, so 16.05. Divide by 1, that doesn't change anything. So for my grams of water that I produce, my calculator tells me 336.82 blah, blah, blah. So now we need to think about sig figs. So my given, I have 3 numbers there, but that 0 is not significant because there's no decimal point. So I have 2 sig figs in my given. So I need to have 2 sig figs in my final answer. So I'm going to chop off the 6 and round that 3 up. So my final answer for this question is 340 grams of water is what will be produced. Okay, so I have a U-try for you to go ahead and work through. If I burn 75.0 grams of methane with plenty of oxygen, how many grams of carbon dioxide will I produce? So this one is similar to the last one. We already have the balanced chemical equation. We can reuse that. We can also reuse the molar mass of methane, but you do need to do the rest of it on your own. So what I want you to go ahead and do is pause this video, try and solve for the video answer, and then replay the video to get the answer and check your work when you're done. So go ahead and pause the video now. Okay, so again, okay, so let's go ahead and solve this. Again, we use that same chemical equation as before. We're then going to set up our factor label table. Remember, our given, which in this case is 75.0 grams of methane, always goes in the first spot. That is a guarantee, 75.0 grams methane. The thing we're trying to find is the grams of the carbon dioxide. So if I have grams of methane up top, I need grams of methane on the bottom. Okay, so if you think about that 4-step process, I have my balanced equation. Now I'm going to take my given and get it into moles. I'm going to then, step 3, convert from moles of my given to moles of my ending compound. And then the final step, I want to convert from moles of my final compound to whatever unit I'm trying to find, which in this case is grams. Okay, so here we have molar mass of CH4, which we already calculated, so I'm just going to use those same numbers over. So we have 16.05 grams per 1 mole. From our periodic table, we have 1 mole of methane to 1 mole of carbon dioxide. And yes, you do need to write this step. Do not skip this. It will cause you to mess up. And then the final thing, I need the molar mass of my carbon dioxide, which I have not yet calculated. I will need to do that. So if I look on my periodic table, I have 1 carbon. Carbon has a mass of 12.01. And I have 2 oxygen, each one having a mass of 16. So if I add those up, that gets me to 44.01 grams per mole. So on the bottom, I have a 1 mole. Up on top, I have 44.01 grams. Okay, numbers up on top, I multiply. Numbers on the bottom, I divide. So we have 75 times 1 times 1, doesn't change anything, times 44.01 then divide by what's on the denominator. So 16.05 divided by 1. Divided by 1 doesn't change anything. So that spits out an answer of 205.654. Again, I need to think about sig figs. I look at my given. This time my 0 is significant because I have a decimal point, so I need 3 sig figs in my answer. So I'm going to chop it off after the 5. Again, 6's round up. So my answer for this question is 206 grams of carbon dioxide. So I hope that helps. If you have any questions, let me know. Otherwise, I hope you have a great day. Bye, everyone.